Hi everyone, welcome back to our channel. In today's tutorial, we are going to learn about integrating a RAG pipeline that we have developed using LangChain into this beautiful front-end interface called Open WebUI. Open WebUI is a open source interface that looks very similar to ChatGPT as shown here. It gives you a clean, user-friendly chat window where you can talk to your AI models just like you can do on ChatGPT. Here you can select any models. These are all the local models that are available. These are all the external models. These are all some of the custom models that you have created. You can call any model that you want to get responses from this interface. So here you will write your message just like you do in ChatGPT, and here you send. After you write, you will get a send message just like you get in the ChatGPT. But the best part is it runs locally and gives you a full control. You can connect it to your own models, your own data, and even your own APIs. In this tutorial, we will make our LangChain-based RAG system work seamlessly within this Open WebUI by building a backend, this one that fits well within the framework of Open WebUI. So basically, Open WebUI talk to our local FastAPI server that was built here, which uses our own documents for answering. We will go through all the key parts of this code that makes this entire integration possible. So some key aspects that we will discuss in this tutorial are how to create these endpoints, V1 chart completions endpoint, and another endpoint, V1 models endpoint. These are two important endpoints that you need to create effectively in order to get proper responses from the Open Web UI. Along with the creation of these endpoints, we will also learn how to plug them effectively into our RAG pipeline and how we return the responses, including optional streaming. We will just learn about this streaming in a minute in the exact format that Open Web UI expects. The big advantage here is the flexibility. You can use your own data, keep everything private, and still enjoy a modern chat UI. This setup is perfect for enterprise dashboards, research workflows, or just personal knowledge assistance, and it runs completely on your machine using your own data. This RAG pipeline requires a FAISS index. This we have generated in our earlier tutorial, this video tutorial. In this video tutorial, we have built the complete FAISS index, and we have clearly demonstrated each step involved in building this FAISS index. So basically, FAISS index means it is something that contains all the document chunks in embedded form. If you want to learn how to develop this FAISS index completely, so please watch this tutorial. In our current tutorial, we are just going to use the same FAISS index. So we just need these two files. So I just copied them here into this data directory. Within that we have a FAISS index directory. Within that we have another OpenAI directory, and within that we have these two files, index.faiss, index.pickle. So we need these two files. So how we got these two files can be learned from our earlier video, and in our current video we just use them as it is. All right, so now let's take a look at how we can set up this FastAPI server that acts as a bridge between Open WebUI and our RAG pipeline. So first, why FastAPI? Because FastAPI is a very lightweight, fast, and a very developer-friendly framework. It lets us build clean REST-style APIs quickly with very little boilerplate code. And most importantly, it gives us full control to expose only the endpoints that Open WebUI needs. In our case, we want this backend to behave exactly like the OpenAI API because Open WebUI expects the endpoints in the same format that OpenAI API works. So we are exposing two main endpoints. Namely, one is this v1 slash models endpoint, which simply tells Open WebUI what models are available. And we will use this to register our custom model name like we have registered here, right? GPT-4 RAG. This is our custom ID that we have given to our RAG model. And the second endpoint is this one, v1 slash chat slash completions endpoint, which is where Open WebUI sends the user's chat messages. This is our main RAG entry point. We will take the input, pass it through our retriever and LLM, and send the answer back in OpenAI compatible format. So now coming to the server setup. So here we are loading some important libraries. These are some standard libraries like FastAPI, Pydantic, pathlib, .env to load the environmental variables, and some basic libraries like OS, time, and JSON. And here we are loading some LangChain libraries. And here we are loading the environmental variables, and here we are setting some basic variables like the path directories, index path, etc. We're also adding this coarse middleware so that the Open Web UI, which usually runs in the browser on a different port, can make requests to our API without being blocked by the browser. So here we are allowing all origins to start, which is okay for development, but in production, you should limit this to your front end's domain for security. So this is done. So once you have set up this coarse middleware, the next step is to set up our main LangChain-based RAG components, which we are doing this here actually. So here we are creating an event on event startup. So in this function, this function will be executed on every startup of this server. So whenever this server starts, so this function will be loaded automatically, and within this function, all of our RAG requirements will start automatically, like including the FAISS index, the retriever, the embedding model, and the LLM chain. Everything will start. Let's break it down step by step. So here first we are loading the embedding model. So we load the OpenAI embedding model using this OpenAI embeddings class. So this model is used at runtime to convert the user's query into a vector format, which we will then use to search inside our FAISS index. So it is important to use the same embedding model that was used when the FAISS index was originally created. In our case, it is text embedding 3 small, and we have already used it in our previous tutorial. So we are using the same here as well. So next we load our vector store, that is the FAISS index from disk using this FAISS.load local function. This index contains all our document chunks already converted into a vector form. And here we are also allowing this allow dangerous deserialization is equals to true, which is required because of the way FAISS stores some internal data. Once the vector store is loaded, we convert it into a retriever using as retriever function, and we configure it to fetch the top 5 relevant chunks whenever a query comes in. And finally, we set up this retrieval queue chain. This chain connects the retriever with an LLM. Here, the LLM that we are using is this GPT-4 model, and here we are setting the temperature to 0, meaning no or little creativity. So we are setting this temperature to 0 to avoid hallucinations from this model. Instead of GPT-4, you can use any other model, GPT 3.5 or GPT 3.5 Turbo or GPT-4 or any other model you can use actually. That's up to you. But here in this tutorial, I'm using this GPT-4 model with this temperature 0 because GPT-4 is good for generating better responses. We also allow return source documents is equals to true, which means that every time a question is answered, we also get to see which documents were used to generate that answer. This is very helpful for debugging and for understanding how the model is reasoning. So with that, our RAG pipeline is fully initialized and ready to handle chat requests from Open WebUI. As soon as the server starts, everything that is in this function is loaded into the memory, the vector index, the retriever, and the LLM chain. And we are ready to move on to handling the chat completions. So this is our next phase. So here we are creating this main chat completions endpoint. So every time a user types a message inside this Open Web UI, for example, this one, what is the definition of CDF, and hits enter, that message gets sent to this endpoint. Which one? This one. V1 chat completions endpoint in a format that exactly mimics the OpenAI API. That's why we named our route as V1 chart completions to match exactly what Open WebUI expects. So basically, Open WebUI expects an endpoint that is similar to the Open AI's API actually. So that's why we are maintaining this coherence between Open WebUI and this endpoint similar to OpenAI. The data that comes from the Open WebUI comes in the form of a list of messages. This includes both user messages and assistant replies if there is any chat history. But for now, we only care about the most recent user message. So in our code, we exactly extract the last message that came from the user. Once we have this user's input, we directly pass it to our QA chain. This QA chain we have created here, right? So we directly pass that user message to that QA chain. Behind the scenes, this QA chain does three things. First, it embeds the query using the same embedding model we loaded earlier. Second, it searches the FAISS index and finds the top five most relevant document chunks. And the third, it sends all of that, the query and the retrieved context to the LLM, which then generates the final answer. Once we get the answer back, we package it in a response format that matches the OpenAI API style. This includes things like the model name, the message content, and finish region like stop. Here we are doing everything here actually. Here we are sending out the answer in this context, in this JSON file basically it is. So we will send that answer with all these details as expected by the Open Web UI. Now, here we have to discuss about one very important feature that Open WebUI supports that we have also implemented in our backend is this this streaming responses. If you have used ChatGPT, you might have noticed how the reply appears word by word, almost like it's being typed out in real time. This is not just a visual effect, it's actually powered by a technique called server sent events, SSE. In our case, Open WebUI sometimes send a flag called stream is equals to true along with the chat request. This means that it's asking the backend to send the reply in small chunks as soon as they are ready instead of waiting for the full answer to be generated. This makes the chatbot feel more responsive and natural. So to support that, we have added a streaming mechanism in our V1 chat completions endpoint. So if the stream flag is true, we use the FastAPI's streaming response to return any event stream inside that stream. We send the data in chunks in the same format, the JSON format, including the model's partial response and the final done event to tell the Open Web UI that streaming is completed. If streaming is not requested, we simply return the full reply in a single JSON response, just like our regular OpenAI completion. So this streaming support is not mandatory, but it definitely improves the experience when using chat interfaces like Open Web UI, where the real-time feel makes a big difference. And finally, for transparency and debugging, so here we are printing few useful things to the terminal, the user's question, the model's answer, and also which documents were used. So this help you see exactly what was retrieved and how the LLM formed its response. So if you take a look at our terminal, so when we type the question user input, what is the definition of CDF? So the LLM generated this answer actually. The CDF or cumulative distribution function is a function of X something something was generated. So this is our final answer, and this answer was generated using this source documents. So this is our source 1, this is our source 2, this is our source 3, and this is our source 4, this is our source 5. These are the document chunks that are obtained from the PDFs that we used as main sources in our RAG application. And now there is one last piece we need to complete our integration, and that is this V1 models endpoint. So this endpoint is simple. It is used by Open WebUI when it first loads. So it sends a request to the V1 models endpoint. This to fetch the list of available models so it can display them in the drop down menu on the front end. So for example, you see it here, right? If you click this direct, you will see all the models that are available, the custom models that are available in this local. So here you see this GPT-4 RAG here, right? So from where this text GPT-4 RAG came here is from this V1 models endpoint actually. So here I have given this GPT-4 RAG. So likewise, whatever the models that you list here in this JSON format, all these models will go there. This ID GPT-4 RAG, this ID match the model name that we used in the response from our V1 chat completions endpoint, for example. So here we used the same model name here. So both these two should match actually. So whenever Open WebUI checks for available models, it sees GPT-4 RAG as a valid option and allows us to select it in the interface. Once selected, all future chat requests will be sent to our local FastAPI server through this endpoint. One key thing that we have to maintain is the structure of the JSON we return from the V1 models should match the format expected by OpenAI's API. So we include fields like ID, object, etc. just like OpenAI would do. So this ensures full compatibility with Open WebUI, which is what allows our custom RAG backend to act like a plug and play replacement to the OpenAI API. So to sum it up, with this simple endpoint, we tell the Open WebUI, hey, here is a model you can talk to. And from that point on, the UI behaves exactly the same as it would with GPT, except that now the answers are coming from your own documents where using your own local RAG system. So that's it. So with the creation of this entire backend code, we have now successfully created this server. Now the point is to integrate it. So how we have to integrate is this one. Go to your main Open WebUI interface. So open this settings. So within the settings, go to the connections. So here you see, right? So Open WebUI will make requests to this one, localhost 8000 port V1 chat completions. So here, if you click this plus button, so you have to put these details like I have put here. So if you click this here, so you have to give this HTTP localhost 8000 slash v1 and the remaining chat completions will be automatically appended. So here I am giving this key none because I have given the OpenAI's API key required to use the GPT-4 that I have given in my environmental variables. So that will be automatically loaded by the LangChain functions. So no need to explicitly give it here. So that's why I have given just none. And here I'm not specifying any models here. All these models are coming from here v1 models endpoint. So here I have explicitly listed these models. So you don't need to define anything here, just the URL and enable this button and then just write none. That's it, and then save it here, then next close it, and that's it. You save it here as well. After that, whenever you open a new chart, it shows up like this. You can here in the direct section, your custom model will appear here. You just click it and then ask the question that you want from your documents. So for example, if you want to see what is the definition of CDF, what is the definition of CDF, it will take a while to answer, and eventually it give you the answer. So this answer came from the document chunks that we have. Okay, and for example, if you want to learn explicitly, so for example, we have this file, right? For example, just take a look at this mprun demo. So let's understand what is this. So mprun demo, what is this? If we click it, it is saying mprun demo is the name of a Python file, mprundemo.py. This contains a function called sum of lists. So if you look at here, yes, it is actually containing a list, sum of lists function actually. So if that is the case, let's see if it can extract the entire code for this sum of lists. Can you get me the code for sum of lists function? That's it. It extracted the code definition sum of lists n. So this is the same code that you can see here. Same thing, right? Sum of lists n, total is equals to 0, range 5, like that. Okay. Yeah, that's it. We have now fully integrated our LangChain powered RAG pipeline into Open WebUI using this fast API server. So To make things simple, I have clearly written all the instructions that I just demonstrated in this video tutorial clearly here in this step-by-step format. So I'll give the instructions to download this file either in the description section or in the comment section. Using the instructions, you can download this file along with this backend server code main.py. You can download all these details following the instructions. In order to start this Open WebUI server, you have to first start this FastAPI server. So to make things simple, I'm just clearing out all these things, and then first you have to start this server. After starting this server, then you have to start this Open WebUI. So I'm just clearing here as well. I'm just restarting the server. So the server can be started using this Open WebUI space server. If you click this, so it will take a while to set up this server. So once you see this Open WebUI, so you just need to type this localhost 8000. If you type this, you will get this one Open WebUI started. So after that, things are simple. You just have to type some question. Hi, what is the definition of CDF? No problem. It can take care of the spelling mistakes. Yeah, that's it. Yeah, that's it for this tutorial. If you found this tutorial helpful, please make sure to like the video, subscribe to the channel. And if you have any questions or suggestions, please comment below in the comment section. See you in the next tutorial. Thanks for watching. Happy learning.